Okay, class, we have managed to, most of you have managed to create an interlocking box with parametric walls, so where we can whatever slide in any direction, X and Y, with a thickness of 3 millimeters. So we use that as fixed, but we could also just put a slider in, but then everything that is 3, for example, if you want to beef it up to 5, I would just probably replace those numbers. But you could also put a slider in. The problem is, if you replace the number 3 panel with a slider, you would probably just use one slider somewhere here and plug in this slider in everything where the number 3 is plugged in, because you might make a mistake and forget one slider, yeah, and then you have different material thickness all of a sudden, which would totally destroy your code, yeah. That's why I used for the material thickness, because it's such a fixed thing, yeah. We know we want to cut in 3 mil, so we might as well just leave it that way. It will simplify the code, so we stick to that. But with this basic code, a rectangle, we create a surface, we extrude the surface, and perhaps move it somewhere. We use the same technique to create those little interlocks. You remember when we made this thing in Rhino, we kind of created these little stumps which we moved up and then subtracted from the panels, yeah? And we do the same in Grasshopper. So again, I just use a rectangle. And I obviously want to start at the same point. Yeah, so we have the point here, X, Y, Z, 0. Yeah, and it creates this little rectangle, but we don't want it there, obviously. We want it in the thickness of the material. And for that, we use again a panel. And then a little trick, if I double click and I press //3, enter, you get a panel. So again, double click on your canvas, 2 times slash, and then whatever number you want, in this case 3, enter. Quick way to make a panel. Because sometimes you need a quick panel, bang, bang, bang. Yeah? So get used to that. And obviously I want this into the X and the Y. Yeah, come on, move over. Don't need this. My computer runs a little bit slow. I hope it survives. Okay, and again we do surface from curves. That's in the surface. This one, very, very useful panel. So, surface from boundary curves. We can sort of hide that for now. Or we can make it more transparent. Quick, which is sometimes quite useful. You can actually set the transparency in your swatch, yeah? So you can, make it a little bit less transparent or more transparent. On the bottom, if you click on your slider and it's the bottom one, yeah? So, which is kind of quite useful sometimes if you want to concentrate on working, still kind of, if you want to see generally when you want to work on as a shape, for example, but you want to clearly see, how you progress with your code. So we should have a surface there now. And now, the way I did it, you think I should extrude this now and then array it. And I did that first And then I realized, it's better. Let's array this surface first and then extrude it. Yeah, you remember when we did this little, you know, we did a little column, square column, and then arrayed it. And I did this in Grasshopper first, but then it proved, it doesn't work that way. I now array this surface according to the height of your walls. Yeah. So, and I could do it. So we go linear array. That's this here. Yeah. Again, for those latecomers, I work with symbols. If you work with texts, you go display. Yeah, here in display, draw icons. Yeah, I like to work with icons, but it's down to your preference. Yeah, because here I can I just look at this without reading and I know what it does. Yeah, for me it's quicker. Okay, I could array this now, and I want to obviously array it into the Z direction, right? So I take this geometry and stick it in there. And I obviously want to go into the Z direction. Double click Z. Stick this into the direction. And now, now you can sort of see, I think it has a certain number in there. At the moment I have 10. And now, and let's just devisualize it because we want to just concentrate on. So at the moment we have these 10 little arrays of surfaces in this corner. And now we obviously want your arrays to fit exactly into the height of your walls. So what I came up with, I need to divide the height of the wall with the amount of arrays I have in order to distribute them evenly into that height. Yeah? So there's a little bit of a math operation, but what I like is it's kind of very visual. So I take the height, so you go back to your so this is our upright walls here, right? And we extruded the upper walls by, in this case, whatever, 112. Make it 120, just to see the change. Yeah. So this is our variable for the extension of the upper wall. So what I want to do is, I want to take the height of our wall. So I take the slider, hang on, and divide it with the amount of arrays I have. And let's say I want to have, at the moment it gives me a number of 10, but I don't want to have 10, I want to have 5 to start with. So I get a slider, yeah, so I have 5 arrays now. And I want to divide the height with the amount of arrays. So I go division. And this is a simple A divided by B division. Yeah? So I take this division here, so the height of my box, and divide it with the amount of arrays I have. And this is my extrusion. So I now get the base plane of my little extrusions, which I want to subtract from my walls. Okay? This is a little bit of a thinking. It's a little bit of a Sudoku here. Yeah? What I do sometimes in the morning, I just work like sometimes for 20 minutes on Grasshopper because it's a bit like a morning Sudoku. It's a little bit like a puzzle. Yeah, when you get into it. So at the moment, I have divided the height of my box with the amount of arrays I want, and now I have an even distribution of the arrays. So I don't overshoot, for example. Yeah. And now I can extrude this. And we know this from this code. We could just copy and paste this, but we can do it. Extrude it. And we have this extrusion. And we again go into the direction Z. And let's say I just want to extrude it, let's say 12 millimeter. And now I have my kind of little interlocking blocks I want to subtract from my walls. Exactly the same as we did in our Rhino file back in the day. Yeah? So, now I need to look at my code and see what we're gonna. So the first thing I want to do is, it's never great to have, I basically want to have the locks sort of inside my panels, but not on the bottom. I don't want to have a cutout here on the bottom. So I want to remove that. And we have something under sets that is very, very handy. We have list items. And then we also have sequences. And there we have something that is called index. So we can delete bits. Yeah? So this is a battery where you can delete certain items in a list. Yeah? And you will, the longer we work with Grasshopper, using these lists and taking bits and pieces of a list is a very useful thing to do. Yeah? At the moment, this is your first introduction into working with sets. Yeah? And I'm very, very bad with it, but I'm using them constantly because I'm okay with mathematics, but I'm not an accountant. This would be great for an accountant because it's a bit like Excel sheets where you can select certain things and filter it down. Yeah. But I realize they're very, very useful. So I can take my extrusions. So this is my list of extrusions. Yeah. But I want to remove something from this, and I want to. The way Grasshopper works, it always doesn't start 1, 2, 3, 4, 5 counting. It starts from 0. Yeah, it starts from 0, 1, 2, 3. So I want to remove the first one, which is the number 0. Yeah, and I think we could always get a panel to check what we get in here. Yeah, and here, so basically, these are our extrusions. We've got 5 extrusions. One starting with the 0. So this is 0, 1, 2, 3, 4. Right? And I want to remove this one here. I want to remove this one here. So I stick in a panel. // 0. Enter. And now, what I get from this list is only these ones here. It removes this one. Yeah? So, this call index, I could also call whatever, if I put a comma in, for example, and number 3, okay, it would then call this, yeah. Hold on, why doesn't it do the 3? Do I have to do a slash? Or a space. Can't remember. No. Hold on, I think for that I need to do this. Not red items. Sorry, I need to look into this again. I just basically, let's leave it for this. Okay. There's a certain way to do this, where you can select various items. Right, okay, so now we have removed the number 0 from this list of 5, so we have 4 interlocking sections. So what we do get is a B-rep. This is a B-rep. A B-rep is a 3-dimensional container. And you can stick meshes into a B-rep. It's just a sort of like a very democratic 3-dimensional space, let's put it that way. Yeah? So this is a B-rep. Yeah? So it contains a 3-dimensional data. Okay. Now I need to check how I did this. Okay. Now I want to move these ones over to the right-hand side of my box. These 4 I want to move over here. And it's obviously just a move to the right. Yeah? So in X direction. And we know this already. We go move. So we take this B-rep. At the moment it automatically moves it up. But we want to go X. And obviously we want to go, we could type it in, but obviously we know the X already. We take the X from our upper code. This is the X direction, yeah, of our upper wall. This is the Y, and this is the X. So we take this X. Oops. No, I want to take this one here and stick it into the X. And now you realize we overshoot because we have extruded this wall from the 0 point to here. And if we move these ones at the same amount, we overshoot by exactly the material thickness. So we just take the material thickness off using a subtraction. Yeah? So we take a subtraction. So we take the material thickness off, /3. So that's the material thickness, our well-used panel. And we don't stick it, we take this one. Hold on, can I? Yeah. It's a command. Yeah. So if you hold down the command and the shift key, you can take a wire out of a battery and move it somewhere else. Yeah? Command shift. Right? Command shift. Yeah, I can take it and stick it somewhere else. Yeah, from here to here. So I take the material thickness off and stick it into my X. And here we have it. So, and now it's a good time to put a few things together. So I want to merge all these little uprights together in one group. And for that, I use a merge. So I want to join what we have here. So these four and these four. I just want to put them together. So I merge them. So I take these ones and these ones. So at the moment I have them nicely. Yeah, sometimes it's quite good to kind of put things together. So I have these ones. And now I take these ones and shift them over into the y direction. Yeah? So again, I move them. So these four here, yeah, I move them onto the other side. And I take the y direction from here hold on. Obviously, I need to do this in the y direction. So I need a y battery. So we have them on the other side. And here again, we have the same problem that we overshoot because the y direction goes from here till here. Yeah. So if we shift these blocks into the exactly direction as we have in the y, they overshoot. So we also need to subtract them by the material thickness. So subtract by the value of 3, and again Control Shift would take this wire quickly need to now see what I did here. Okay, yeah. Down there on my code, I just basically, again, and this is the point where I sort of start, reorganizing my code a bit to make it a little bit neater. Because it can get awful messy. No. And then obviously when you work extensively on code, you need to kind of also learn how to kind of bulge them together. And I will show you a nice trick at some point. So these are all of my extrusions. So we have the front one, and we've got the back one, and I just merge them. Yeah, using a merge component. So that these ones and these ones. Okay. Why did I merge? Okay. Now, what we have now is our interlocks in our walls. So the great thing is now, if I shift my walls, the interlocks go with it. But the good news is, if I want to, let's say, have more little teeth, right? Let's do 8. I can make, and then I see, they're a little bit big. I don't want them that long. I want them slightly shorter. Let's make them 6. Yeah? And say, I want it perhaps a little bit lower. Where's the extension to the height? Floor. Where's my height? It's here, isn't it? Yeah. Let's make it like 110. So whatever you change in height, width, interlocks, everything is adjustable. And that's the great thing about Grasshopper. Yeah, you know, to make all these variations in Rhino, on the Rhino surface, you would have to go back to your initial block. Here you can just adjust it with moving a few sliders. Yeah, and that's you know, that's just a huge amount of optionality built in your design process. Yeah. So I group this and I call it interlocking. Let's save this. Now, I quickly put this away. Now, what we want to do is, we obviously want to subtract the right pieces from the right bits. Yeah? And I do this. I first want to see what do I have. Yeah? And for that, I use, again, I go to my sets. And there's one battery that is called list item. And basically, list item is, it shows you what you have in a battery. Yeah. So let's have a look. What do we have? So basically, what I want is, I want to take my 4 walls, and I want to subtract the interlocks. Yeah. So at the moment, if I hone into this, what do I get out? Whenever you want to know what you get out of a panel, there's one closed B-rep that's indicated with 0. So that's the first wall here, right? That's weird, because we seem to have here a whole number. I thought we had 4 in here. Yeah. The thing is, if you zoom in here, you get little options. Basically, you can increase. This is just the first item on this list. You have to increase this list. So if I hold on. And if I show you this is a B-rep, so the first item on this list is this one. The second item on this list is the back one. The third item on this list is this to the left. And the fourth one, because we always start with 0, is the front one, right? So all these, so we can actually basically get rid of this. So we have 4 pieces in this list. These are all the 4 walls. are listed in here. Yeah, they're all B-reps. Yeah. So this is the B-rep sign, but this is based. These are all 4 B-reps. And now we have done this, I think, already with the intersecting. Didn't we use an intersecting at some point? Anyway, there's perhaps a new battery I introduced. So this is, I think we have used solid difference. So I want to obviously subtract your interlocks from the walls, right? So, and we do that with a solid difference. Okay. So, and here, just need to check how I did that. Okay. So I take all my interlocks here. So these are all my 4 interlocks. And I want to take them, and so basically I want to take them from the front and the back. So where are my fronts and backs? Let's just copy and paste this. Just plug them in to kind of visualize it better. Okay, so this is the side, this is the back, left, front. So I want to have the front and the back. And I want to subtract, so the front, the back and the front. So I take the front one in and the back one in, and I hold shift down because I want to get 2 wires in. Yeah? So if we hide this all, and we hide this all, and I think we need to hide this one as well. Now we get the front and the back cut out with our extensions, right? So it's all a little bit sort of like a puzzle. So I was working on this last week, and I got really into it. And there were various versions, and because you can cut corners, and then you can think I do the rest in Rhino. But I thought, oh no, I really want this completely parametric, yeah. And then you just need to kind of figure out what puzzle does fit into what, yeah. So it's kind of a nice. I like this. This is interesting, you know. How do I do this? Okay, right, and we do the same game again with our side panels, but now we use these ones and we subtract it from our side walls, right? So the side walls are, hold on, I need to visualize this. Yeah, and these are obviously, we need to cut these grooves out, yeah? So we do the same thing, solid difference. So we take our side walls that have not been cut, shift, hold down, and we take this away. So, we hide this. Perhaps we hide this as well. So now we have the side walls cut out and the front walls cut out. Right? Let's save this. And now again, whatever change we make, let's say whatever, we want to have it, we want to have less. It's 6. And you see, it takes a second to calculate. And it changes everything. And that's the great thing. Yeah, so you have, and what I have here and I can show you. Now we will deal with, so for example, this battery will then export it, extrude, make it to be projected onto your floor. But next week, I think, because I want to keep it sort of in smaller steps now. So I will stop the recording and